Hello everyone, welcome to Chip Confessions. In our previous video, we saw about the types of the procedural blocks in Verilog, and in this video, we will be seeing about types of assignments in Verilog. So what does assignment mean? Assignment means we are updating or we are giving a value to a variable. That means especially the output variable. If we are assigning or updating any values to that output variable, it is called as assignment. And we have two types of assignments in Verilog. These are the major classifications we have. One is the continuous assignment and another one is the procedural assignment. So what happens in continuous assignment? As the name itself says, continuous assignment means the value, the output variable, means the value of the output variable will be updated continuously based on the changes of the input variable. Means we will be using an assign keyword here and we will be using the output variable here in the LHS, and which is equal to any expression consisting the input variables or any input variable directly. So this is how we do continuous assignments in Verilog. Means we will be taking then assign keyword, and using this assign keyword we will be assigning this output variable with the value of expression, means the final value of this expression or the result of this expression or any variable directly. So how this works? Means we will be having an output variable, and whenever there is a change in this input variable, for example we have an AND gate here, and these are the two inputs. This is a two input AND gate. Very simple example I have taken. This is the output Y and the two inputs are A and B. So what happens here is we will be updating this output variable whenever there is a change in any of this input variables or both the input variables. Means whenever we have changes or the update in any one of the variables or both the variables, we will be updating this output variable. So how we can write this? We will be using the assign keyword and then output variable, that is y that is equal to expression. As this is the AND gate, the expression will be A and B and ending with a semicolon. And if you want to assign directly a variable, then you can do is A is equal to B. This is how you can directly assign the value of B to A. Means whenever there is a change or the update in the value of B, the value of B will be updated to A. What happens here is whenever there is a change in any of the values of A and B, the expression will be evaluated and the evaluated result will be updated to Y. Then why it is called as continuous assignment? Means as I told you, whenever there is a change in the expression, immediately this output variable will be updated, and this is continuous till the end of the simulation. Once the simulation starts, this continuous assignments will start working, and till the end of the simulation this will be active. So this is continuous assignment. And one more thing is this output variable should be of wire type. As I told you, we have two kinds of data types, major data types, which can be synthesizable, that is wire and reg. And whenever we are using with the assign statement, that is a continuous assignment, this should be, that is the output variable or the LHS should be of wire type. Means you are assigning it in a continuous way, and this reg cannot hold like the multiple changes. Means that wire can hold the multiple changes, means there will be a flow of data. So it is also called as assignment which models data flow type of design. Means whenever we are modeling a data flow type of model, we use this continuous assignment. We shall see that in our upcoming sessions. We have behavioral model, data flow model, gate level model. We have these many kinds of models, and means that is the way, means these are the different kind of ways we can write a Verilog code while modeling a digital circuit. So data flow model is nothing but it will be showing how the data flows in your circuit. Means what we are giving here is A and B. We are telling how the circuit behaves. We are not telling it in a higher level, like this is how, this is an AND gate and A and B. Means we are not telling in a high level what happens. You will just describe the circuit, how it works. But here you are actually depicting the circuit, and by looking that itself you can know what kind of hardware it is going to make. So this is showing the data, means the flow of data inside the circuit. Using these inputs you can easily tell these are the inputs and this is what happening in the circuit, and what kind of value or what kind of result or what kind of calculations you are performing or what kind of evaluations you are performing by using this expression, and then you are assigning it to the output variable. So this is what continuous assignment is, and you can have multiple continuous assignments in your design. That is, when you have a module, and here name of the module and end module. As this is a design, you have to include the ports here, or you can include the ports inside the module also. That is, we are including ports here, and here you just have to give assign, and you can give your expressions, and you can give another assign and expression. So it is like you can use multiple assignment statements. There is no end for these many assign statements. You have nothing like that. You can means your design can contain, or your module, whatever you are designing, that can contain any number of assign means continuous assignment statements. That is your assign statements, and these assign statements will be updated or will be executed simultaneously. Means how I said the procedural blocks, like no matter how many initial or the always blocks you have, everything will start to execute simultaneously. In the same way, this assign expressions or the continuous assignment statements will start executing simultaneously, and they will execute in a concurrent way. Means simultaneously they will execute. So what you have to keep it in mind is, there if there is a dependency in the variables, like you are giving A is equal to B and C, and then again you are taking D is equal to A and E, something like that. So this is, so what is happening here is, and just okay, I can see like this. What is happening here is, this first sentence is, first statement is okay. We are ANDing B and C, and we are assigning the result of this AND to the A. But what is happening in the next statement, whenever we are using an assign keyword here and here also, this will be executed in a simultaneous way. Means at a time these two will start executing, so there will not be a proper value for A. Means as these two are executing at the same time, this cannot be resolved, and these may contribute to race around condition. That also we will discuss in our upcoming videos. So this will happen something called as race around condition. That means, in a simple words, what we can say is, the simulator cannot decide the value what A can take. So sometimes it may result in don't care condition or the unknown values also. So what we have to keep it in mind is, whenever you are giving or whenever you are designing a circuit in a, means whenever you are coding in a data flow style or continuous assignment style, what you have to keep it in mind is, you have to take care of this dependencies. Whenever there is a dependency and it If it can be resolved, then it is no problem, it is fine. If it cannot be resolved, then it can result in unknown values, or what we call as X propagation of unknown values it can result in. So we have to take care of these things. What we saw here is, first we saw what is assignment. Assignment means you are giving or updating a value to a variable, and we have two types of assignments majorly, that is continuous assignment and procedural assignments. In continuous assignment, the value or the output variable will be updated with the value or the expressions or the result of the expression from the RHS side with the help of the assign keyword we will be using here. Means we use the assign keyword, the name of the output variable, and then in the RHS it will be either expression or a single variable, and the result of this expression calculated will be assigned to the output variable. Means whenever there is a change in the input variable contained in that expression, this assign statement will be automatically triggered and the output variable will be updated with the whatever the calculated value based on the changed input value. So this is what assign or the continuous assignment is. Then what we have to see is the procedural assignment. So procedural assignment is nothing but whatever the assignment we do inside the procedural blocks. Yes, and one more thing is this continuous assignment, it is a separate thing. Means we will not include this continuous assignment inside any of the procedural blocks. So what are the procedural blocks we have? We have initial block and always block. These two are the procedural blocks we have, and the continuous assignment statement with assign keyword, this should not be there inside this procedural block. The simulator will throw an error. Okay, one reason is with this assign keyword we have to use wire data type only in the LHS. Means the output variable should be of the wire type, and this wire type we will not use in this procedural blocks. So the thing is, with this assign keyword we need to use this wire type of output variable only, and inside this procedural blocks we have to use reg type of output variable. So this assign we will not include in this procedural blocks. Okay, so now we shall see the procedural assignment. So in procedural assignment we have two procedural blocks, that is initial block and always block. In this procedural assignment we can include in any of these blocks. We can include in initial block also, we can include in always block also. So we have two types in procedural assignments, that is one is the blocking assignments and next is the non-blocking assignment. So these two are the type of the procedural assignment we have, blocking and non-blocking. What is blocking? Blocking means, as the name itself says, if we have multiple lines of code, if it is a single line of code it doesn't matter, but when there are multiple lines of code, for example we have a is equal to b, then just for example I am taking, and we have c is equal to d, and we have a is equal to f, like this. If we have until and unless this first statement is executed, the control will not move to the second statement, and until and unless the second statement is executed, the control will not move to this third statement. So this is what blocking is. The execution of the further statements or the next upcoming statements will be blocked until and unless the current statement is executed. So that's why it is called as blocking assignment. We use equal to symbol here. Means whenever we are updating any value to the LHS, what we use is single equal to, and this is what this single equal to will represent blocking kind of assignment. And what is non-blocking assignment? This non-blocking assignment will tell, right, whenever we are assigning some values like and this non-blocking assignment we use something called as less than or equal to symbol. This is what non-blocking assignment operator. So what we will be doing is A non-blocking assignment B, and then C non-blocking assignment D, and E non-blocking assignment. Yes, if this is like this, what happens is the value of RHS will be evaluated, but it will not be assigned to this LHS immediately. What is happening here is the value of B is evaluated, or value of the RHS is evaluated, and it is assigned immediately, and the control goes to the next statement. Value of the RHS is evaluated and it is assigned to the LHS immediately. Then it will go to the next statement. Like that, the evaluation or the execution continues. But what happens with the non-blocking assignment? With a non-blocking assignment, what happens is the value of the RHS is evaluated, but this will not be assigned immediately, but at the end of the time step, this value will be assigned. What is called as end of time step? End of time step means we have in Verilog something called as event scheduling. This event scheduling or the event scheduler will tell you how the execution happens. Usually we use it, or usually this was brought into picture just to avoid the race condition. Means this event scheduler says how your code is executed. We have something called as active region, inactive region, non-blocking assignment region, and postpone region. Means this regions, means the execution is divided among these 4 regions, and these 4 regions will tell you how the execution happens. Means we have active region where this blocking assignment, evaluation and assignment both will happen. But we have something called as non-blocking assignment region where this assignment happens. Means in the active region, the evaluation happens, means the evaluation of the RHS happens in the active region, and in the non-blocking region or in the non-blocking assignment region, which we call as NBA region, in this NBA region the assignment to this LHS will happen. Means the time step will be divided among the 4 regions. That we will be, don't worry about that as of now. We will be seeing that in our further videos. Here what you have to understand is very simple. In blocking assignment, what happens is, in blocking assignment, this RHS is evaluated and this LHS is updated immediately. Okay. What happens in non-blocking assignment? This RHS will be evaluated, but after some time this LHS will be updated. Means this LHS will not be updated immediately. Okay. And one more thing, this is non-blocking, which means this execution will not block the execution of this, and this execution will not block execution of this. Means this non-blocking assignments execution will happen in a simultaneous way. Means in a concurrent manner. Everything, this all non-blocking assignments will execute simultaneously. Means these values or the value of this RHS of all the RHS what expressions we have will be evaluated simultaneously, and at the end of the time step the values of these things will be updated to the LHS in a concurrent way or in a simultaneous way with respect to each RHS and LHS. So this is what blocking and non-blocking is. Don't get confused here. Don't worry about the time step, or don't worry about the event regions, whatever I said. Only thing you have to understand is in the blocking, RHS is evaluated and it is immediately assigned to the LHS, and these statements will be blocking kind of thing, as the name itself says, means until and unless the current statements executes, the control will not go to the next statement. This is what your blocking statement or blocking assignment is. When means if it is a non-blocking assignment, what happens is the evaluation of the RHS will be evaluation will happen and the assignment will happen after some time, means immediately the assignment will not happen. Evaluation will happen immediately but assignment will not happen, and as the name itself says, it is non-blocking. That is, this the execution of a first statement or the current statement will not block the execution of the further or the upcoming statements. This will, means the execution will happen in a concurrent way, and once the evaluation of the RHS happen and when the non-blocking assignment region comes, this value will be updated. So in a simple words, blocking, evaluation and assignment happen at the same time. In non-blocking, evaluation happens but assignment will happen after some time. Okay, means immediately this assignment will not happen. And what we have to see here is one more thing. This blocking will result, or whenever you use blocking kind of assignment in your design, it will result in combinational circuit. And whenever you use non-blocking assignment, it usually result in sequential circuit, such as latches or flip-flops. And why, you may get it out why this blocking assignment will result in combinational and why non-blocking results in sequential. The thing is, combinational, if you see any design or any combinational circuit, as previous example I take is AND gate, whenever we are giving or whenever we are taking an input, this output will be given immediately. Well, this is not waiting for anything. And output is reflected in an immediate manner whenever there is a evaluation of this expression or whenever there is a evaluation of this RHS side. Means out in a combinational circuit, output depends only on the input and it need not to wait for anything else, and it will be reflected immediately whenever there is a expression or evaluation happens. But this is not the case in non-blocking assignment. Means for non-blocking assignment, we can consider a flip-flop or a latch. We have something called as input here and we something called as control here. It may be enable or it may be a clock. Enable in the if it is a latch, and clock if it is a flip-flop. So we have input here. It can be anything. It can be D or T, as we have only one here, or if you have multiple inputs, it will be like either SR or it will be either JK. And we'll be having Q and Q complement or Q bar here. So what happens is, whenever there is a input we will be giving, and based on this control, what happens is this output we will get. But the thing here is, whenever we are giving an input, we will not get this output immediately, because this is depending on its previous output also. I'm sorry, because this will be depending on previous output also. So the sequential, what is happening here. So by default, whenever we are using a non-blocking assignment, this evaluation will happen and it will wait till the assignment is happening. But this we cannot do in combinational. Here if we do like this, everything is happening in a sequential way. means one after the other it is executing, and these kind of characteristics we cannot bring in blocking kind of assignments. For example, if there is a single flip-flop, it doesn't matter much, but consider where we have multiple flip-flops we have, and we have to give, for example, we have to give the same input everywhere. Okay, at this time what we have to do is this has to be evaluated and assigned simultaneously. So all the flip-flops we have to assign simultaneously. At that time this non-blocking assignment will help, means as the assignment is happening in a concurrent way and it is not blocking the execution of the other statements, modeling a sequential circuit will be easier when compared to the blocking statements. So whenever we are using the blocking statements, as the result is updated or reflected immediately, this will be resulting in a combinational circuit on, and whenever we are modeling a sequential circuit, as the result will not update immediately and it will wait for its previous output to get updated, and it is given as an input, this non-blocking assignment will be helpful in modeling the sequential circuits. And one more thing is, as a good design trait, we should not mix this combinational means blocking and non-blocking assignment statements in a single block. In a single procedural block, it is advised not to mix both blocking and non-blocking, because see, if you are not designing anything or if you are just testing something in your test bench, you can do anything in your test bench. But whenever you are designing to get a proper design which is working properly, what you have to do is you should follow some design rules, and in the design rules this is also one of them, that is you should not mix blocking and non-blocking statements in a single block. You can take multiple always block in one always block, or in one procedural block you write all blocking statements, in another procedural block you write all non-blocking statements, and you take that in a single module, means in a single design. If you take multiple procedural blocks and in a separate procedural blocks you are using blocking statements in one procedural and non-blocking in another procedural block, that works fine. But whenever you are designing something and if you are mixing blocking and non-blocking, it may result in unusual behaviors of the design, or your design may not behave in the intended or a proper way, which is means it will not give proper results, it will not behave in a proper way according to the specifications. So this is what for today, like we saw about the types of the assignments in Verilog: continuous assignments and procedural assignment. In continuous assignment we have to use the assign keyword and it will model the data flow kind of modeling in Verilog design style. And we have the procedural assignments where we have both blocking and non-blocking assignment types, and blocking usually used for combinational circuit modeling and non-blocking is usually used for sequential circuits modeling. So this is for today, and please stay updated for further videos. For that, please like, share this video and subscribe to my channel. And thank you for being with me, and in our next video we will see the event scheduling as I told you today, so that you will understand how your code is executed. Means if you understand the regions where your code is getting, where your lines of codes are getting executed or getting scheduled, so this will help in understanding how your code behaves, how the execution is happening. This is the core. Like before you are going to write some code, if you understand this, you can write a proper code. You will understand how it gets executed. Means we are getting technically into the how the execution happens. So in the next video we will be seeing about the event scheduling, and this is for today's video, and we shall see in our next video. Thank you.